Okay, so this next period of instruction is going to be on Fire Direction Center, not just the boards on their own, but you will have a little bit of time to take a look at how the boards work, as well as how the aiming circle works itself. We're going to be going over the nomenclature and items for the plotting board, for the aiming circle, how to set up a plotting board, and how to set up a gun line a little bit, and then how to plot gun lines and do linear targets and do those different sheets that we learned earlier today. All right. A few things for you to write down here. The aiming circle publication is going to be AMC 0204. I say again, AMC 0204. And the other aiming circle publication is going to be Training Manual 00476 Charlie. Training Manual 00476 Charlie. For FTC procedures, you're going to refer to TC 3 TAC 22.91.
29 dot.
Yes, Training Circular 3 TAC 22.91. That is Mortar FTC procedures. That is the title for that. If you pull it up, it'll look like this one right here.
Is that a booklet, sorry? Or is it
This is a booklet.
Is it just digital?
It's a digital publication, yes. Out of all the files that I sent like last week or something, all of these that I'll be referencing are in there. So during this course of instruction, this period of instruction, it would make sense for y'all to pull those out, and you can use them as references as we go along. But I just know, right? Most people here probably haven't just read pubs before. So it's going to be a little bit hard to digest that information. What I would recommend is look in the table of contents, find the thing that we're talking about, and then go to it, so that way you can kind of get a basis of understanding per the pub while we're talking about this stuff. All right, cool. First thing first, we're going to go over the plotting board. There's 4 methods to convert a call for fire to gunline data. One of them is the plotting boards. The other one is the LHMBC. Another is Mortar spot plot. And the last one is the math method. So your plotting boards are basically going to create a circular map that you can use angular corrections on to create gunline data. The LHMBC is the lightweight, handheld mortar ballistic computer, LHMBC. That basically just has all of the information like built into it. So all you have to do is plug in the numbers and then it creates the answers for you. Just kind of shits them out. And then you have Mortar spot plot, which is similar, but Mortar spot plot is a part of the ATAC system. The ATAC system being those little phones that you see people have sometimes that have like military maps on them, and they can control UAS with them. They can also control. They can also basically get mortar data, gunline data from it as well. If the two ATACs are connected to each other, networked, say the observer has an ATAC and then the FTC chief has an ATAC, the observer can open up his ATAC, send that call for fire through that digitally, so then he just receives a message basically. The FTC chief receives the message and then puts in the data, puts in this information that he needs, and then it'll shit out the freaking data for the gun line. So then there's no radio transmissions whatsoever. He just receives it, and then cool. All right, section like fire engage equip, go into the gun line commands and making sure he writes down in his computer records. With all of that, and then there's the math method. There is an equation that you can use for any basic adjust fire grid mission where you can get the direction and you can get the deflection for the gun, and then you would still have to use the whiz wheel for your range and your elevation. That is the least preferred method because I've only met 3 mortarmen that know the equation. I am one of them. We're not going to go into it. We're not. I promise you, if I don't lose you guys when I get into the plotting board, I will lose you when I go into the math. Okay? I promise you that. That is probably the hardest thing known there. Maybe not. It's just you gotta be really out there for that. Okay, so those are your methods. Do I have any questions on the methods before I go into the plotting board? Is that the one with the nose? Okay, good. All right, so this is your M16 plotting board here. You have 3 major components. You have your base, which is your white frame in the back. You have your azimuth disc, which is the actual disc that spins. This is the azimuth disc. And you can see, now that I take the azimuth disc off, the base has a grid layout on it, all right? If anybody knows, right, this grid layout, the size of these boxes, there's a certain scale that pertains to that too. The scale is written at the bottom. What?
They're each 50 meters, right? 50 meters.
All right, so the scale is 1 in 12,500, which means each green box is 50 meters, like you said. So, we'll get into that in a second. But components, your base, your azimuth disc, your range arm. This is a range arm. It's not just a ruler. It's got a different metric, so it doesn't really, regular rulers don't work for this. It's to scale specifically for the M16 platform. All right, and then you have your vernier scale. Your vernier scale is on top of your board on the base, and it correlates with the numbers on your azimuth disc. We'll go into what the vernier scale does as we go through the process here. All right, so I'm just going to write some stuff down here real quick while we are waiting. Does anybody have questions to start out with? up there is a rough step-by-step on how we set up our plotting board and how we get gunline data. Are you holding your breath? Okay. Breathe. All right. So first things first, I should have brought an eraser, but first things first, I'll discuss this thing so that way it's nice and clean for us to use. I'll go over the terminology and what all this stuff means in a second. Last person doing 2 different missions at the same time.
Fire missions at the same time. Yeah.
Are any of you guys on the board?
No, just outside. Where did RL?
I heard that shit all night. It was so funny. I mean, like this is his 40 minutes ago, woken up to like not on a nice hit like this. And the staff sergeant doing the fuck was on straight duty.
Oh, he was just like laying down right there. He's like, "What did you just say?"
I was like every 40 minutes in here, so I, I'm like, man, dude. No, the rest of the weary.
All right, so I've cleared my board, and before I get started with anything, I'm going to set up my bottom right portion. For the guys in the back, if you guys can move to where you can see without disturbing the aiming circle. I'm going to just do it right here. So hopefully you can get good eyes. All right. Make sure you're not in the way of that. Okay. So what I'll be doing first is write it up on my board so that way everybody can see. If I have, I'll leave that there. If I have my entire board, this is my board, this is my freaking azimuth disc. In my bottom right corner here, I'm going to have my 81mm mortar symbol. I'm going to have space beside it so I can put the grid for it whenever I receive it. Then I'm going to have my FO symbol with space behind it so that way I can put the grid. I'm also going to have a few key terms at the bottom with space so I can put the numbers below them. These key terms, this is your grid intersect, this is your mounting azimuth, and this is your referred deflection. Grid intersect, mounting azimuth, referred deflection. So, I'm gonna go back to my board here. I'm gonna do this real quick. Throw my mortar symbol up, throw my FO symbol up, make space for my GI, mounting azimuth, my RD.
Sorry, so for the board itself, this is just like zooming in. So let's say on the map we have, the 150,000 map, this is just zooming in on one square.
Right, so scale, right? Take a look here. When I'm talking about scale, I'm going to reference 1 kilometer right now. 1 kilometer is going to be 4 boxes, or two square boxes. So this is 1 kilometer. Make sense? So if I split this in half, what is that? What's half a kilometer?
500. meters.
500 meters, right? So half of a kilometer is 500 meters. If I split that 500 meters in half again, what's that?
250 meters.
250 meters. Do we understand? All right. Each green box is 50 meters. Each black box is 500 meters. That is something you should have written down. Each green box is 50 meters. Each black box is 500 meters. So if each green is 50 and each black is 500, how many greens are in the black? 10, right? 10 laterals. So total is going to be 100. So I'll write that down for us. All right. So we have that. Now, our first step is we're going to determine our direction of fire. We're going to determine our direction of fire. That will be when you're looking at your map, like your actual map, or whatever you're using, little GPS, whatever, you're going to see where the potential enemy is going to be at in reference to the position that you're going to go to. So, you're moving through Quack Pass. You're set up on the west end of Quack Pass, about 600 meters from the adjacent units. All right? Your suspected enemy is coming from that west end of Quack Pass, about 1.6 kilometers to the north. What would, like for cardinal directions, northeast, southwest, where would I want to put my direction of fire?
Towards the west.
Towards the west, why?
Because they're coming from the west.
But we are also on the west of Quack Pass. We're on the west of Quack Pass, they're coming from the west of Quack Pass, but they're coming from like 1.6 above us. So that
Would it be the opposite, the east?
Okay. All right, so you've got some mountain ranges here. You have a set of mountain ranges here, and this is where our mortar firing position is at. This is Quack Pass. All right, there's also a set of mountain ranges here and mountain ranges that come across. So if this is Quack Pass, we're set up on the west end. We have suspected enemy coming from the west end about 1.6 kilometers north of us. So if we have in that direction, what's our direction from? North. North, right? So we have to establish that in mills, right? So what we would actually do, we would have on our maps where our suspected enemy would be. We would take our protractor from our MFP. We would see the actual exact like middle number on your map that the freaking direction would be. All right.
That's 0 to 5999, right? So if there's, isn't that goes to the 6,000?
Sorry.
Is it for that number? It's like it goes to 6,000, but it's like 0 0 when you get 6,000.
No. So mills operate from 0 to 6,400. Shit. 6,400 is also 0. So in a circle, actually, best example is the azimuth disc says this. This is 6,300 right here. 6,300. It goes to the next 100
and it starts at 0. 100, 200, 300, so on and so forth. 3200, 4800, 6200, 6300, and then 0. Make sense?
Yes, it does.
Okay. Note that other countries have different mill systems. So, NATO mills, this is how we operate. Other countries do not have the same amount of mills. I found this out recently because I was doing land math with a Japanese protractor because I thought it was cool. And that Japanese protractor does not operate in the same amount of mills. I did not notice that until I was 10 degrees off from every single point I was looking. Exactly 10 degrees every time. Which was kind of weird, and I was like, why is that happening? Because I was exactly 10 degrees. I ended up doing an offset and then finding my point every time. But it's because the Japanese operate in a different mill number.
Is there a reason why they do that, or did you prefer?
Great question. I'd ask a Japanese person. Well, you'll deploy out there. Maybe. So, you can ask them. But this was recently that I found that out. Alright, so we've now put our protractor on. We've determined that it's not exactly north. We'll call it 0050. Alright, so we've determined our mounting azimuth because we shot from here to here. That is our mounting azimuth. So out of the 3 numbers, there are direction of fire is right there. Direction of fire is also going, we'll call this mounting azimuth just because it makes life a little easier. All right. So we've determined our mounting azimuth. So now I'm going to input my mounting azimuth at the bottom here. I'm going to put it down there on my plotting board. 0050. All right. So now we know that we are shooting from here to here, right? Note that from the center of this plotting board, it only goes up to about 3,200, around 3,200. So how can we maximize our range to get to 5,844? Go lower on the plotting board, right? So what we're going to do is we're going to determine our grid intersect. Grid intersect is where the plotting board is, where the pivot point on the plotting board is. I'm going to input a grid, a 4-digit grid, to where now I can maximize my range. Important things to remember for that. When you're determining your grid intersect, you want it to be towards the direction of your potential enemy, towards the direction of your mounting azimuth, but you don't want it to be exactly on there. Because say that this is where your pivot point, what's that?
Is it for the little circle in the middle of the board?
Yes, because say there's a target there. Now you can't do anything because it's on the pivot point. So you want to have it like off to the side. So that way it's out of the way, all right? If you know that there's like no enemy coming from this way, or maybe even most likely there's no enemy coming from this way because your friendlies are in this area, right? So, but this is also like a known point, might be important. So we're gonna try to put our grid intersect over here, all right? So I want it to be like right there. I'm gonna build out my map real quick. I'm gonna say 72, 3, 74, 75, 76, 1. I'm looking at my map and then that's what it looks like, right? Then I want to put my grid intersect somewhere around here. So brighten up, I'm going to do my eastings first. My grid intersect is going to be 7, 2, and then my northing is 1, 3. So I'm going to mark down here, my grid intersect is 7, 2, and 1, 3. And it's going to look like 7, 2, then you're going to do a slash, and 1, 3. 7, 2, 1, 3. Now that I have my grid intersect, I'm going to superimpose my grids. So like I said, my grid intersect is what for my pivot point? It's like where the pivot point is, right? So I'm going to go down 2 clicks, down 2,000, and left 2,000. So right here and right here on my plotting board. If this is your pivot point here, I'm going to go right here and right here. So that way I can maximize the amount of space I have on my board. Because if I draw a line through this, it's going to end up right in that corner there.
And that's on the square, on the map. Sorry, it's like kind of clicking in my head, but like you're drawing on the grid itself on the plotting board with
Yes.
that data.
Exactly. So I'm about to do that now. So eastings first, I'll do 7, 2. I'm going to put 7, 2 right here, and then obviously I'm gonna draw out the rest of it. So 7, 4, 7, 3 there, 7, 1, 7, 1, and 7, 0. Okay, so I have my eastings written out. Now I'm going to write out my northings. So my northings started with 1, 3. Put 1, 3 right there. 1, 4, 1, 5. And then I'm going to go down 1, 2, and 1, 1. All right.
So I have a question.
What's
So
up?
are you just picking out anywhere in like the grid you can put it, or is this like you chose like these parts of general for a reason? I'm just kind of confused on why you chose what you chose.
So what I was explaining was when I go from the pivot point and I go down 2,000 and I go left 2,000. The purpose for that is in this corner right here, it ends right there. So I'm maximizing the amount of space that I have from here to here. Does that make sense?
Yes.
The board, you can only go at 3,200.
But now I can go from this point to this point, which is almost double that. So that's more than the max range. So now I can effectively do that. But let's see, where's our plot? Our plot's at 7, 4. We know that it's around the 7, 4 area. My 7, 4 is right here. And we'll say that it's like further, or it's like closer or something like that. We'll call this. Just fix it a little bit here. We'll call this 7, 3 to make it a little bit better, and then we'll call this 1, 4. All right. So I know that my plot, say you're using your protractor and you're getting an actual 8-digit grid, right? I'm going to call my mortar grid 7310, and then I'll do 1120. That's my 8-digit grid for my MFB. I put my protractor on my map, I found it, and I got my 8-digit grid. And I'm going to do the same thing for my, technically speaking, at this point, you're not going to actually have a target. But, so we'll get back to the target whenever the FOs spot it. But I am going to add an observer and say our observer's right there. So he's at, we'll call him 7225, 1100. So now I have those grids
for the MFP and the FO with
Plug that in.
yes, with my grids now put on the board, I can actually plot just like I would on a map. Just like I would on a map. The only difference is the scale of the map. Okay? So I'm going to take 7310, 1120, and remember we're working with 8-digit grids, so that last digit of the grid is how many meters? Okay, so 10-digit grid is effective to what? No, so 10-digit grid is effective to 1 meter. And an 8-digit grid is effective to what? 10 meters. So if I were to change that last digit of the 8-digit grid, it would change by how much? 10 meters, right? So if I went from 7310 to 7311, that would be a 10-meter change. Each green box is 50 meters. So
1/5 of a green box.
1/5 of a green box would be a 10-meter change. You see how now we're getting extremely focused on how accurate we are. This is why it's extremely important for plotters to be accurate at all times. All right, so I'm going to look at 7310, 7310. I'm looking at this line, this big black line here. This is the 7-3 easting line. And 10 is only 2 green boxes. You understand how I'm getting that? Because 1 green box is 5, or like 50, but it's 5 with an 8-digit grid. So 2 green boxes is 10. Makes sense? If I want to express it in a 10-digit grid so that way people can understand, 1 green box is 50. I need to get to 73100. That's 100. So I need to go 2 green boxes. 2 green boxes. Does that make sense?
Yes, good.
So I know that I'm 2 green boxes over from the 7-3 line, the 7-3 eastern. Now I'm going to do the same thing for my northerns. It is 11200 expressed in the 10-digit grid. 11200. So I'm going to go to the 11 line. I'm on the 11 line. And then it's 200, so how many green boxes is that?
That's 4.
4 green boxes, all right? 4 big. Okay. So now I'm gonna go up 4 green boxes from those 2 boxes. I went 2 boxes right, now I'm gonna go 4 boxes up. So I'm on those 2 boxes, and I'm gonna go 1, 2, 3, 4, and I'm gonna make my plot right in the crevice of those boxes. See how small that plot is? Why is that important?
So you don't get super off.
Better refine our position.
Refine your position. If my plot is bigger than 10 meters, I'm going to not be checking with my secondary plotter, right? So, but what I like to do for these is we're not going to be firing anywhere near our position. So I like to make my MFP huge, but the plot itself needs to be small. So plot's small, and then my MFP is going to be this big. Cool. Just that way I can definitely see it. So then when I look here, I look at this, and then I look in there, and then there's my plot. Easy enough? Okay. Something to remember that I just completely butchered, but it's fine. The op-terming graphic needs to be facing the direction of fire. So if it's facing 0500, this would be like facing directly up. All right. So I'll like redo that or something. There. I want to erase this one. Just for understanding. All right. So now, tip to remember: when you're plotting, you're always plotting with 0 indexed. Indexed meaning it's on the center line. 0 is always aligned on the center line when you're plotting. Why is that?
That way, you know northeast, southwest, and then when you get the OT factor data and all that from the FO, then you know what to plug in the board and get up there north of you or north on the board.
It's not zero out if you're plotting on a point.
Right.
You're plotting on a box.
Exactly, because think about it. With the azimuth disc, the grid is still like there. It's just written on here. So if I'm on 0, these grids are correct. But if I'm not, and then I decide to try to plot it again, how would I even plot that? If I were to plot the same grid, I would end up being completely off. So you want to be zeroed out while you're plotting. Okay. All right. Now I'm going to plot the FO. 7225. I'm going to go to my 72. This is my 72 easting line. I'm going to go to 25. How many green boxes is that?
I don't know if you choose half, right? So
So I'll express it in a 10-digit grid. 72250. How many green boxes is that? 5 green boxes, which is half of a black box. All right. So 7225. Cool. I'm there. And then 11000 is how many green boxes? 2. 11000 is how many green boxes? 0. Because it is on the 1-1 line. So I'm on the 1-1 line. I'm going to go to 7225, and I'm going to plot on 11000.
So that's
That is my FO. So my FO position is plotted. I don't have him as big because I don't really give a shit about him. Like, he's not important. He's not as important in this instance. Just remember, I'm expressing these in 10-digit grids right now for your understanding. Whenever you get around to this, you will be doing it in 8-digit grids. Because we don't need to be operating in 10-digit grids because we're not accurate to 1 meter. We're accurate to like 35 meters. So we operate in that 8-digit grid space, all right? So this is just for your understanding currently. Now, I have my direction of fire, or my mounting azimuth is 0050. On your azimuth disc, I'm going to show you right now, from 0 to 100 is how many ticks? 10. So 1 tick is how many mils?
10 mils.
10 mils. In between that, there's still 10 mils. So 0 to this tick is 10 mils. 10 mils to this tick is 20. So 10, 20, 30, 40. 50 is the big line. 60, 70, 80, 90, 100. Make sense?
Sure.
Okay, here's where you guys are going to to determine that last digit on your mils. I'm going to break this down as Barney style as I can. You have, we're going to call it, I'm going to do a crazy mounting azimuth just so that way it's underlined. 0, 4, 1. No. All right, so our mounting azimuth is now 0341. Whoop. Wow, no response there. All right, so 0341. Look familiar?
Yes, sir.
All right. Yes. All right. So from here,
13.
For those first 2 digits, I'm just going to look directly at my azimuth disc so I can find it. So I need to look for the 03 on my azimuth disc.
Yeah, that means you spin it right first.
So I can just look. I'm looking for 03. There it is, it's 03, so I'm going to spin to it. So now I'm on 03. That's my first 2 digits.
Now you get 41.
My third digit, I'm going to find from the ticks, because remember we said each of them are 10, right? So that's 40, right? So 03, 1, 2, 3, 4. So I'm going to go to 03 and I'm going to go to 4.
And that's just however many away, like from.
Yes. So
So if you had like a. Alright,
take this for instance. I'm counting left to right. Yes. Counting left to right now. 100, 200, 300. 310, 320, 330, 340. Right? When you're just talking about numbers as their own. As mills, it's 0300, 0310, 0320, 0330, 0340. Okay? Now that final number, you're going to do, we'll call this from the ticks, all right? And that final number, you're going to find via the vernier scale. Vernier scale, you'll see it over there, but it looks a lot like, oh, don't murder me for my drawing skills here. It's gonna be interesting. All right. And then we'll call it Alright, so we're at currently, we'll call this 0200 right here. Your vernier scale. This is interesting. Alright. 1, 2, 3, 4, 5. 1, 2, 3, 4, 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 10. All right. So this is what your vernier scale looks like. You're going to notice if I take the azimuth disc off, up here, it is only the top end of those ticks. So they're going to correlate with the ticks on the azimuth disc. So I'm going to go back to 0340, and then I am determining, what am I determining right now? I'm determining the mounting azimuth, right? So you have to separate in your brains deflection and azimuth. Deflection works in Lars. Azimuth works in Rouse. What that means, and these are going to go under rocks, by the way. Lars is left, add, right, subtract. Rouse is right, add, left, subtract. Make sure that gets written somewhere. Rouse.
What is Lars again?
Left, add, right, subtract. Lars, left, add, right, subtract. Rouse, right, add, left, subtract. Lars is in reference to deflection. Rouse is in reference to azimuth. A good way to remember this is, what is the nomenclature of this thing right here?
That's the line board.
Okay, this is
Azimuth
board. Azimuth scale.
This
Disc. Azimuth disc. But remember, azimuth. Azimuth, the numbers on here is azimuth. These are azimuth. Alright? The numbers are going clockwise. So right, add, left, subtract. Right, add, left, subtract is clockwise. Left, add, right, subtract is counterclockwise. These numbers on the azimuth disc are going clockwise, which makes them right, add, left, subtract. Am I losing anybody yet? Do we have any questions?
Where you said the azimuth is the rouse? The azimuth rouse?
Azimuth is right.
Oh shit.
Once you're done with all this, can one of us get a rep at it to
Yes.
more understand it?
Or at least another example of this as well. Not tracking, but like, I think if I get another example. concrete.
Okay. Tomorrow, we're gonna go like, get into it. I'm already kind of getting into it a little bit more than I wanted to.
Well, Smith was right.
Azimuth,
Azimuth rolls.
Azimuth, rowels, deflection, lars. Think about azimuth clockwise, deflection counterclockwise. If that helps you.
You want to use the blue marker? It might show up better on the screen.
Does it not show up?
I don't think it shows up.
I'm not too worried. I mean, it is for y'all, but
Sergeant, can you look at
Honestly, my
the
boards.
utility?
it's not gonna show up either way. What is that?
Can I look at the board like utility before we move on to like?
Yes, and what I will do for y'all is I'm going to pop up in the second board, so that way y'all can kind of like touch it.
I think the way we're gonna learn this is like learning some of the nomenclature stuff helps.
It's more of a tomorrow thing,
Yeah.
just because of the way that I have this set up, is I'm gonna get you through the basics of everything, and then anything that you guys have questions on, we're gonna go over.
So is there any move to the 0341 in this?
Joe,
Like, is it like already at the part where it's supposed to be?
you moved it
Oh,
whenever you
did I?
grabbed it, so. It'd be nice if Viramontes was here, I already talked on this stuff.
He said you got it all.
And then you move it to the floor right here, right?
So yeah, 4, 1, 2, 3, 4, go.
And then you just move one tick.
One tick.
Okay, so I'm going to update this board with the data that was given. So Barker, can you go ahead and give me the MFP grid?
Group 7310 1120.
Okay, and FO grid?
72250 1100. I have actually the extra 0 on the first one.
That's fine, alright. And then the GI,
72 over 13.
7213, alright. We don't have an RD yet, can I get the mounting azimuth?
034
034
1.
1. Alright. Cool, so I'm gonna take my GI, I'm gonna throw it, I'm gonna go down 2,000, I'm gonna go left 2,000, and I'm gonna put them in there. For the easting, 7.2, and I'm gonna put 1.3. Alright, 7.2, 7.3, 7.4, 7.1, 7.0, and then for the 1.3, I'm gonna go 1.4, 1.5, and then 1.2, and 1.1. Now my grid is set up, so now I can plot my points. 7.310, 1.120. We're gonna go 2 green boxes. What's up?
Kind of was random when you were going over the GI. How do you get this 72 and 3?
So that's when you're looking at your map and you're determining based off of where you are and where the assumed target is, that rough direction, and then getting a more accurate mounting azimuth from putting the protractor on and then shooting on Mill's grid.
So you're just putting what you got on your map. Just putting-
Yeah, you're just looking at it on your map. So like, basically, shoot a direction from here to here, and then that's your mounting azimuth. But you won't necessarily have like an actual target grid. You'll have a suspected enemy to the north. So then you're like, okay, cool. North would be like 0, 0, or 0, 0, 0, 0. But you don't want to do 0, 0, 0, 0 necessarily, because then it's going to make your math annoying, because some targets would be on the left-hand side, some targets would be on the right-hand side. And you don't want to necessarily do that. So you can make it 100 or 200 off of that, like 0, 2, 0, 0, or something along those lines. Right now, I just did
0341, 0341, just as a reference, so that way we can see how the vernier scale works. But for my GI, as you're saying, I know that my enemy is to the north. I cannot hit max range with my board if I use the pivot point. So I'm going to go below it. And how I do that is I basically take a mental picture, and I'll show you this way. Take a mental picture of the plotting board on your map. If my grid, my pivot point was my MFP, am I reaching that target? I am not. So what I need to do is I need to find something in between so I can reach both. Right? Does this help? But also, if I have a target right here, so in this area, I wouldn't be able to hit it because the pivot point's right there. So I'm going to have to go offset a little bit. So what I did is I looked at that, I looked at these, I wanted to go about half the distance in between, and then I offset. And then this spot right here is where I decided that my grid intersect is going to be.
And you're going down 2,000 because of the situation, it just works best, so that's standard.
Standard. So down 2,000, left 2,000, because whenever these two grids intersect, it'll hit this corner here, and this corner to this corner is max range, and this corner to this corner is also max range. That's why I want my MFP as close to one of those two corners as I can, so that way I can max range. Because now if my target's up here, I can, that's like what, 1, 2, 3, 4.5 clicks, and I can still reach and touch it. Make sense?
Yes, sir.
Does that answer your question?
Yes, sir.
Okay. All right, so I said 7310. Cool, I'm gonna do, this is my top-term graphic. And then 7225, 1100, right there. It's your FO, and I got all that now. So now I'm gonna spin my mounting azimuth like I did with the other one, and you can follow along as well. While you're right there. I'm gonna go to 03. I found my first two numbers. I'm gonna find my third number, which is 4. I'm gonna go 4 ticks, 1, 2, 3, 4 ticks. And then I'm going to look at my vernier scale. Right now, are we dealing in deflection or azimuth? Azimuth. So I'm gonna look at the azimuth side of my vernier scale. And what I'm going to do is I'm going to align the next line with the 1 on the vernier scale. So currently right now I'm at 0341. And what I'm saying for that is if we take a look over here, if I'm shooting for azimuth right now, I would be at 019. Because, so this is 0200, right? We are going right add, left subtract, so we're going clockwise.
Yes.
We have not passed 0200. So that puts us in 19. All right? 19, this is the 5, so 5, 6, 7, 8, 9 ticks. So we're at 199, and we're right in the middle here. All right? Right in the middle. So now I'm going to look at my azimuth side of my vernier scale, and I'm going to see which one lines up. The 5 lines up the most. See these two lines, how they actually perfectly align?
Yes.
So my full numbers, all 4 digits, would be 01, or 019, correction. Yes, 019. Yeah, all right. One second, I gotta check this out. Sorry, even I. Cool. So, my bad. I actually didn't fuck up that. So I'm at 019. So this is your 01 spot. I'm gonna go 9 ticks over, and then I'm gonna look at my vernier scale, and it's at the 5, so that's my last digit, 0195.
Oh, because that's where perfectly lines up. We're using that number because it's lined up like that.
Yes.
Because we're looking for here for 1.
So if I were to go to 0341, I'm going to spin to 03. I'm going to go 1, 2, 3, 4. So I'm at 034, and then I'm going to make that line up with the 1 on the azimuth. So now it lines up perfectly. So I'm there.
Which line, Sergeant?
Oh,
So you go to
Any of those lines needs to line up with the 1.
oh, so if it lines up to that, just go to that, that's your one. Whatever on the top scale lines up.
That lines
with that
up the
number,
azimuth?
you just move to there.
Yes.
Okay, understood,
Yes.
understood.
And that's one of the harder concepts to understand when it comes to the blotting board, just because the veneer scale is kind of crazy.
We went 0, 300. We went 1, just a 2 rest of 3, 4.
No, that's
All right, get a mental picture, and we're gonna push.
that's fine. That's fine.
All right, I need to keep moving on, so if you guys are gonna reference on that. That's why we're over there. All right, so I'm at 0341. With that, now I have my mounting azimuth. I'm going to change the mounting azimuth because traditionally with our mounting azimuth, they're going to be rounded to the nearest 50 because they are estimates. We don't actually know where the enemy is yet because there's a difference between a mounting azimuth and the direction of fire. Direction of fire is the exact direction that we're shooting. Mounting azimuth is the assumed direction that we're going to be oriented. All right. So 0341 was an example of something we can utilize the veneer scale. I'm going to go ahead and put us at 0350. So change your mounting azimuth to 0350 as well. And then all I'm going to do is I'm going to go to 03. And I'm going to do 5 ticks. 1, 2, 3, 4, 5. And the last digit is 0, so I'm just aligning with 0. Make sense? I'm at 0350. Now, we're going to find a referred deflection. Our referred deflection is determined by where your guys' where the sights are actually oriented to the stakes. So after the aiming circle does its bit and gets you guys aligned on the mounting azimuth, then it's without disturbing the leg or mortar, refer your sight to that number is the referred deflection.
You put that number in the drag mag.
No.
No.
Get into the aiming circle. That's why I'm not talking about it. No, I'm still recording. All right.
So we were talking about the
Right. So, say your aiming circle gets you guys laid on your mounting azimuth. You guys are in your positions, and they did the freaking gun landing, point century, point identified, entry deflection, blah 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 blah. Ready for first recheck, deflection, blah 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 blah. Ready second recheck, 0 mils out anyway. Once you guys are laid, and they say without disturbing the leg in order to refer your sight to a certain number. That number is your referred deflection. It is determined by where you can lay your stakes in correlation with your terrain.
Where the backyard is leaning in, like below the rim, would that be like 3, 2, 0, 0, 1, 1, 0, 0, just straight ahead, and it's like throwing it on?
If you are laying in at 3200, you're laying in your stakes directly on that direction, on that mountain. Yes. If you're laying in at 0000, or as I like to affectionately call it, balls, you'll be laying directly backwards from that mounting azimuth. But you can lay your stakes anywhere. It is just determinant on where you have the space to do it. You'll get into a bunch of scenarios in the future where you're in a really, really good MFP, but there's not a lot of locations to put your stakes. So say you're in your MFP here, right? You can't shoot your stakes forward because you're in really good depth lay, and
And your stakes would either go like all the way up the hill, or you just wouldn't be able to see, right? Or there's not enough space. And then behind you, say there's like a huge drop off, so you wouldn't be able to put your stakes there either. You could put your stakes out to the left or the right, right? But it has to just have a mill number tied to it. So if you want to go directly right, then it would be 1600. When you go directly left, sorry, it would be opposite. When you go right, it would be 400, and if you want to go left, it would be 1600. Usually, the numbers that you'll see is 3200 facing front, balls facing back, 0700 canted out at a 45, and 2700 canted out on the 45 facing back. So this time, we're going to do This time, we're going to do 2700 because that's where our stakes could go. Allegedly. So we're going to write preferred deflection at the bottom, 2700. What's our next step on our step chart here? We have the mounting azimuth. We found our grid intersect. We superimposed the grids. We plotted them. But what's next after that? Superimpose the deflection. So, how we superimpose the deflection? We are indexed on our mounting azimuth currently. All we do is we write our preferred deflection right where the friggin' mounting azimuth is. But we're going to express it in 100s, so it's just going to be 27. Yes, that's going to be 2700. So where the azimuth of 0350 is, the deflection of 2700 on your site is there. That makes sense.
Now you know where your site frame in there. Site of your mount.
The best way to do this is to show you. Alright, so what I'm going to do is we're going to step away from the board real quick. We're going to set up a gun. Right here.
Just put it in the base plate and see how it works. Someone will help you hold it.
I'm going to do a shotgun now at the end. Alright, go off. Best way to do it, just gonna hold it like this. And I'm gonna shotgun like that. I'm throwing my spades into the deck, and then it's going to open the chest. Alright. You know, can't really down. Good. And I'm not going to do the rest of the law right now because we don't necessarily need it. Although that's cool. So, site. All right. Where is north in this one? Does it not work?
North is,
Okay. North from the barracks is almost always freaking Arkansas Tower or Fairmont Tower. So yes, north is going to be this way. So say for instance we lay in at we'll say 0350. So we're laid in at 0350. The reason why I changed that is if this is north, 0350 is probably going to be like right here. So that's just a little mental math, right? So we're laid in at 0350. Now, I'm in here without disturbing the leg or mortar, refer your sight to 2700. We're going to turn my sight to 2700. My cannon did not change. It is still oriented on that mounting azimuth, but now I have just aligned the deflection of this sight to this mounting azimuth number. So now, if the deflection were to change and I were to move and do a large, then that angle would change. That I'll get into later. But now, my states are out this way. If I were to change my number by 100, then it would change the direction I'm facing. It would still be the same difference though, because left add right subtract and right add left subtract. Let's kind of go over some people's heads, but for now, we understand that I'm on the mounting azimuth here, and then my referred deflection is just setting in the states to where they are also aligned to the mounting azimuth based on the deflection on the side. Okay, cool. Did this demonstration help, or was it just a waste of time? Okay. Out of action.
just a move. So this is just knowing the plotter to know which way the stuff's facing.
They have to determine based on the terrain, based on where they can lay this thing.
But writing it out, actually like that would just be the board movie, they know which way it is.
Yeah, so the aiming circle guy would have already determined it by then before they would write it down.
And they're just writing it down, that way they know on the board that they've all the shit here, or?
Yes, because they need it. They need it for when you get gun landed. Because you find the deflection and an azimuth every time in the direction. You're gonna have to do it the same way. You're not too short. You're not. It's not too long. Grab the breech blow. There you go. There you go. You got it. Okay. So now that we understand the correlation between mounting azimuth and the referred deflection, we're going to superimpose the rest of the deflection numbers on the board. We're not going to go the full freaking circle. But what I need you guys to notice is we're at 2700, referred deflection, we're at 2700 deflection, and we're at 0350 azimuth, correct?
0450 28.
What are we saying?
Saying 0450 28, so we should go there for reflection.
Okay, deflection is Lars. Azimuth is Rose. So remember, your azimuth goes clockwise, your deflection goes counterclockwise. So if we go right, what is the next number?
26.
26, all right? So we're expressing it in 100s, similarly to how the azimuth disc has it. So I'm going to put 26, 100 mils from my referred deflection. So I'm at 0350, at 0450 azimuth, I'm going to put 2600 deflection. And I'm going to do the exact same thing
3 more times. Okay? Because counterclockwise. Deflection is counterclockwise. Azimuth is clockwise. Alright, so now 2700, if I go left, what's the next one?
228.
28, and next one?
29.
29, next one?
30.
0, next one?
31.
Alright? In school, they want you to put 4, they want you to go left 400 and right 400.
Is the reason for it, or?
Just because this is usually like your cone.
Oh, you're section.
Like it can be section of fire, but you think about it this way: you can fire everywhere, right? But if you're firing in this direction, you only have like 500 meters to work with. They just want you to do 400 meters on each side.
Sure.
All right. So I'm going to spin back to my mounting azimuth here, 0350, with my referred deflection on it, 2700. Now my board is set up. What's my next step?
Parallel plot.
Parallel plot, but I don't have anything to parallel plot with yet. So we'll divide this up actually. These Marines would be in the office at 15:30 for a break. Alright. So, next. Put a line there because this is all when we set into the MFP. Now, once we receive a call for fire, we can move into the rest of this. So you receive. Okay. You receive a call for fire, and I'm going to put the grid over. All right. You receive a call for fire, and it says, brown one, this is green one, just fire, over.
Roger. Anybody?
Just fire on or something.
I thought he was saying, or for.
Either way. Grid. Whatever grid zone designator. 7, 1, 7, 5. 1, 4, 2, 5. Over.
Roger. Follow 7125 1425.
2 by technicals in the open.
Roger.
2 by technicals in the open.
You want that one repeated as well?
Yeah.
Roger. 2 by technicals in the open. Out.
Cool. All right, that's your call for fire. We know that there's 2 by technicals at that grid. So now we're going to plot that grid. So before we plot anything, we have to do what?
Get your data,
Data.
or your mounting azimuth, your is that the grid indicator?
That's already done.
What's that? So you just plot again?
When we plot, we have to be on 0. You have to be on 0 when you plot. Or else this isn't a map. If it's like this is just an angular measurement. It's only a map when you're on 0. Okay? So I'm going to index 0, and then I'm going to plot my point. 7175, 1425. Once again, all I did was I'm at my 7.1. 7.5 is 1 black box and half of a black box because it's 750 meters out of 1,000. And then 1425 is half of a black box, which is 250 meters. Right? So black box, 500 meters, 250 meters, half of a black box. So I just went half and half. So there's my plot right there. That's my target. I'll wait for you.
There's no loss. So 1-4 up to here, and then the 2-5. You're only going towards the half a box.
So start with Eastings, then go to
Yeah. So 7. You go over to 7-1, and then 7-1, 7-5. So full blocks, and then other half.
are you going left, right, and up.
So right here,
Yes.
and then you're going up for one floor, and then over only half right here.
Okay.
That'd be 2.5.
All right, remember, you're following that line, so you did 7175, you're following that line up. And then 1425.
Yeah, right there.
No, it's gonna be 2 boxes. 2, so remember, 1425 is half of the black box, 2500, or 2500. 150 meters.
250 meters is half a box.
Half of the black box, yes.
Black. So if you're just going up, then you're going over again. Oh, you keep going up another half. So I've got it mixed up in my head. So right here, so you're going up half that black box.
Yep. I'll circle that. There you go. Alright, so that's your target. Alright, now, the next step was what?
Next
Parallel plot.
Oh.
What do you think parallel plot means?
So you're going over your other point, or the 2.7 where it's at, and plot line, and then get the data from between there.
We're not gonna plot lines. We're just going to align the MFP with the target. So, something to remember for this is the MFP will always be on the bottom. So, if I did it like this with the MFPs on top, I'm incorrect. My MFP is always going to be on the bottom. What I'm going to do is I'm going to align this dot, my MFP, with the dot for the target. It's going to be exact as possible. So, I'm noticing I'm kind of getting like a rough adjustment here. This dot is 5 boxes in. It's in the 5th box right here, and I'm looking at this one. This one's also within the 5th box. So now I'm gonna make sure that they're in the exact same spot in both boxes. All right, take a look at that. So they should be exactly parallel. And the way that you can reference this, if you struggle with just looking at it, you can put your range arm up to it, and you should be able to see through your range arm that it's parallel. If it's not parallel, you're wrong. Apparently wrong.
So Sergeant, which is this supposed to be this where the sight is?
This is parallel plot. The sight is not aiming at this. This is us. We're about to change the gun data, so that way we can orient on this target. Right now, we're not oriented on this target at all. We're facing freaking this way. Once we get the new gun data, it'll shift us to where the cannon is facing the target. Sight's always gonna just face the sticks.
I'm on it, Sergeant.
For sure.
Yes, Sergeant.
We'll see. All right, so now what I'm going to do, notice that my referred deflection, the ones that I wrote out, does not get to this point. So I'm going to go ahead and write them out a little bit further so that way I can reach out and touch this. So 30, 31, 32, 33, 34, 35, 36. Now, my referred deflection is right there, so now I can use my numbers. I'm going to get a series of information. There's 2 ways of doing this. There is DAR. DAR is deflection, azimuth, and range. And then there's DARCE, which is deflection, azimuth, range, charge, and elevation. I affectionately call this one Darcy. Per the clubs, or any school that you'll go to, DAR is the information that you need to put on your flag.
deflection, azimuth, data, charge, elevation.
What?
Deflection, azimuth, and range for Derek, and then Darcy's deflection, azimuth, range, charge, elevation.
Yes. Originally you said deflection azimuth data, and I was like, yes, it is deflection and azimuth data. Okay, so I want to find my DAR or my Darcy. So what I'm going to do is it EAT?
Yes.
Okay. Where's the other two?
They're putting their shit away right now.
Alright, so I want to find mine. I'm going to go with Darcy just because that's the easier way to go through this. I want to find my Darcy. I am already parallel plotted, so now I'm going to refer to my vernier scale here. First thing first is deflection. So with my deflection, which numbers am I looking at? Am I looking at the numbers on the azimuth disk, or am I looking on the numbers that I wrote down?
Which one you go
You're correct. So remember, deflection is the superimposed numbers, and then azimuth is the azimuth disk numbers. So for deflection, I'm going to look at my deflection numbers. Or am I going left to right or right to left?
Turning left to right.
That's right.
Or no, right to left if you're going backwards into deflection.
I'm going right to left because right and left. Right? So I'm going to look at my first two numbers. My first two numbers, I'm going right to left here. I see 3, 4, and then I see it does not pass 3, 5. So my first two numbers are 3, 4. Then I'm going to count how many ticks it passes before it reaches 0 here. I'm going to like draw a line for 0, so that way we see as a reference here. So that's 7. Now I'm going to count how many ticks. So from 3, 4, it's 1, 2, 3, 4, 5, 6, 7. So my third number is 7. Now I'm looking at my vernier scale on the deflection side. I'm going to see which line lines up the most. I can already tell it's the 5. The 5 aligns the most. I'll let you guys take a look at that data real quick as it stands. Just don't move the disc. Just take a quick glimpse and sit back down. We're going to keep going.
Can I quickly use this?
Yes. We're going to go ahead and take a 5-minute break.
Sorry.
So come back at 13:36.
Subject.
What was that YouTube channel you said that they teach?
Checker hold.
Checker hold.
Okay, so we're going to continue. We got our deflection of 3, 4, 7, 5. Now, without moving our board, we're still parallel plotted from our MFP to our target. Now we're going to determine our azimuth. Because we tied the azimuth and the deflection together by superimposing that referred deflection on the mounting azimuth. Now, every time we parallel plot, we can get our deflection and our azimuth without moving the board. Does that make sense? Kind of. Alright, so I'm parallel plotted, and then whatever number comes from here, the numbers that I superimposed are going to be the deflection, and the numbers that are already on the azimuth disk is going to be the azimuth. Every time I parallel plot. So now, and I just shifted it, so you gotta fix it. Okay. So now I'm looking at my azimuth, and azimuth I'm going clockwise. So I'm looking 5, 7, 5, 8, 5, 9. It does not pass 6, 0. So my first two numbers are 5, 9. Now I'm going to count the ticks that it passes by. Is it 1, 2, 3, 4, 5, 6, 7. So now it passes. It passes 7 of them, so 7 is going to be the third number. Now I'm going to look at the vernier scale on the azimuth side to see what the number is
that it matches the most. And just here. And it looks like it aligns with the 5. So my last number is 5. So my deflection is 3475 and my azimuth is 5975.
Don't mind me, I was checking this TC here, and there's not. Nope.
So now we have our deflection and our azimuth. A thing to remember for both of these, since they always correlate, the last 2 digits, when you add them together, it will always equal 0. So what's 5 plus 5? Cool, 0, right? 0 at the end of the 10. Same thing for if you add the last 2 digits from each of them, so the last 4, right? 75 plus 75 is what, 150? So it's still 0 at the end. So either way you want to do it, just take those last 2 digits, add them together. If they equal 10 or 0, you're good. Cool? The reason why is because they're still working opposite, and it's the angle theory thing that I'm not going to get into right now.
I kind of actually want you to. I want you to blow these dudes' minds.
I almost got them with the vernier scale. It took a minute.
It's like the easiest thing to understand with this. It just works because it works.
Okay.
Literally it.
I guess, yeah. So now I'm going to get the R for my Darcy. That is my range. So all I'm doing is my range arm here, affectionately called the range arm.
Call the
It
ruler,
gives you-
see what happens.
Because it gives you range. Like the range arm gives you range.
Who would have thought?
There's a 0 at the end. I'm going to put my MFP plot on the 0. I'm not going to put it on the corner. I'm going to put it on the 0. And then I'm going to follow it up to see where my target is. And I'm just going to leave it right there. My target is in between 3.3 and 3.4, and there's a tick in between 3.3 and 3.4. So this is 3,300 meters and 3,400 meters. The tick in between 3,350. It's in between 3,300 and 3,350. So, as an estimation, 3,325. So my range, I'm going to call it 3,325. If y'all want to take a look at this range real quick, you can. And you can also look at Barker's if you are you doing it?
I'm kind of just backtracking, trying to figure it out.
Parallel plot.
I just kind of running from there, kind of like
Did you already get range?
3,325 meters.
Okay. What was your deflection?
Deflection was 5,975.
What? That was your azimuth.
No, 3,475. My bad.
Okay, cool. So we're checking false. Did you get those numbers, or did you just write them down?
I wrote them down when you said,
Okay,
so I figured it more time to go through. So I kind of just like trying to figure it out if you won.
Sure.
Until I stop everything. But
We'll do that. It's fine.
Wait, actually, I'm kind of like stuck on the parallel plot. I can really say that. I don't want to get too far back. Exactly like, why did you move to weighted right now instead of like keeping it on 0, 0?
So the best way to explain this is if I'm on 0, I'm using a map right now, right? If I were to put a protractor on my MFP and then shoot my azimuth out this way, it would give me the same thing as if I parallel plotted. But since I'm parallel plotting, I have to do this so I can utilize the vernier scale to get my data. So if you're using like a map, you could just protractor, you shoot that, and it would give you an azimuth. But where's your deflection? That kind of ties into the math method of getting data. But once again, like I said, we're not going to do that because you know what? You guys can remind me on Wednesday if we end up having extra time to go over stuff. Ask me about the math method of employment, and
And then I'll blow my brains
I'll delete it. Cool, so I'm parallel plotting. I'm getting back on parallel there. And I have my deflection, I have my azimuth done, and then I already got my range. Now, you've done the things that you need to do for your plotting board. That is why doctrinally you're just going to find DAR, because that's what's on the plotting board, and then the rest of it comes from your whiz wheel or your TFT. So charge and elevation, so everybody's seen a whiz wheel before? Cool, so with your whiz wheel, I'm going to spin to 3325, and it's going to give me a charge of 3. So in my CL rate charge 3, and for my elevation, it'll give me 1188. That's a different whiz wheel. So that's a TP round, so it's going to be different because it has a different weight and distribution. So you can take a look at that if you want. So now I have my Darcy for my first thing, or for my first set of data. Now I'll take my computer record. I'll show you guys what that looks like tomorrow.
A lot of visuals.
Yeah. You could pull it out today if you want to do that. See the need.
Yeah, if you're not gonna do it.
Then I'll take my computer record, I'll jot down that data. I'll jot down everything else I need for my fire command, and then now I have the data to give you guys your gun line shit. Section, firing HE quick, gun 2, 1 in the adjust to get the effect. Deflection, 3, 4, 7, 5. Charge 3, elevation, 1, 1, 8, 8. Boom. So now you guys have just taken the data from a call for fire, done some black magic, and came out with gunline data. So now you guys get up on that data, you freaking fire it, and then they give us a correction. First thing first, we can go OT direction. So I'll call. They'll say OT direction is 6250. So I'm going to write OT is 6250.
Yeah, Mark, I recommend writing on the bottom.
Sorry?
Is that something they give to us?
They give it to us. We can't, there's no possible way that we can know OT direction. The only way that we could possibly know it is if we have them plotted and the target plotted, we could parallel plot the FO with the target, and it will give us their OT direction, but
So it's a rough estimate.
it'll give us a rough estimate. They're going to give us exactly what they want for direction based off of their corrections. So you want to go with what they say, not what's on their board there, in that instance, for OT direction. So 6250, remember when I said that you only plot on 0, right? This is the only instance that when you plot, you're going to plot on the OT direction because the corrections are based off of their OT direction. So left-right wouldn't make any sense if you weren't oriented in there to how they're facing the target. Because they're facing the target, say, McCombs. Say McCombs is my target. I'm facing, as the OT, or as the observer, I'm facing the target, and I need to do a correction of left, so that way I'm on Barker. If I got that left correction, but I'm on 0, it wouldn't be exactly the direction that I need it to be. It would be off.
That 90 rounds that I was telling you about, where now Sir Humphreys is left rights are going to be, if Hayes is the firing order as well, or now his that drops.
Oh yeah, for Hinton.
Yeah, I just use the 90 route set because it's the easiest one to understand.
Yep, exactly. So we're always going to plot the corrections or the adjustments with the OT direction indexed. So do you have the OT direction indexed?
Yes, I do. 6250.
Indexed. Because that's what the response to
That
it.
is not 650.
No.
6250 is going to be at the 0 on top of the word.
6250.
Good, that's right. So now, they're gonna give us a correction of left 200. So I'm just gonna write left 200 up here so that way I remember it. And I'm on the OT direction. 200 is how many green boxes?
That's gonna be
4 green boxes. So the exact position that the plot is in that green box, I'm going to mimic on the next box that it's going to be in. So if it's 4 green boxes, I'm going to go 4 green boxes over, 1, 2, 3, 4. And I'm going to put the plot in the exact same spot in this box as it is in the other. If anybody wants to take a look at that, that is the exact same spot in that plot, or in that box, as the other one is. Sure. Okay. Then, now that we've done our adjustment, I can parallel plot with that new position, with that new target. It's the same target, it is just our adjustment on said target. So I'm parallel plotted to it, and then I'm going to get my deflection, azimuth, range, charge, and elevation. For my deflection, I'm parallel plotted. I'm going to look up here on the superimposed numbers. I'm counting 3, 3, 3, 4, 3, 5. It does not pass 3, 6, so my first numbers are 3, 5. I'm going to count how many ticks it goes past. 1, 2, 3. It does not pass 4, so my third number is 3. Then I'm going to look at the vernier scale, and it looks like it is aligned with. Looks like it's aligned with 6. So my deflection is 3, 5, 3, 6. Now I'm going to look at my azimuth, which is the numbers already on the board. I'm going to count from left to right. 5, 6, 5, 7, 5, 8, 5, 9. It does not pass 6, 0. So my first two numbers are 5, 9.
Find a ride from base to conference. I do. Did you put it in there? Gotta do that.
So my first two numbers are 5, 9. I'm going to count how many ticks it passes. 1. It does not pass a second, so my third number is 1. I'm going to look at the vernier scale on the azimuth side to find my number for, or my fourth number. I'm looking. Oh, you know what? Did that wrong. So, deflection, I looked at my deflection and I came out with 3, 5, 3, 4. I look at my azimuth and I come out with 5, 9, 1, 6. I add 4 plus 6, it equals 10. That makes 0 at the end, so we're good. Now I'm going to use my range arm, find range. Just about 3,400 meters.
I need that last number for deflection.
3, 5, 3, 4.
Yeah. How?
Vernier scale.
We go on the linear scale. So go through 3, 5, go back 1, 2, 3, and that last 4.
That last 4 is you're looking at the deflection side of the vernier scale and you're seeing which number lines up the most.
You need to get up there.
So it looks like your 5 lines up. Or your 4. Or your 6 actually.
6.
6 lines up. Okay, so you're checking 2 with me.
3, 5, 3, 6. So I have to go through and then.
Now, okay, now look through your azimuth.
Add these lines over here.
Yes.
While he's doing that, I'm looking for my range on my whiz wheel. 3400. It's charge 3. Elevation 1172.
Only the same one that lines up with.
So then, gun 2 deflection, boom. Freaking 3, 5, 3, 4. Charge 2 elevation. Or sorry, charge 3 elevation 1172. Now you guys have your adjustment data.
So 5, 9.
And we'll keep doing that until we get our fire for effect, and then we'll get our intermission.
5, 9, and there's a few numbers line up here again, or?
Yes.
So 4. Or that's the last one.
That would be 4. Yeah.
So 5, 9, 4. And that last number is 4, 0.
Sorry. You're on aspect.
No, you're at 5, 9, you're 1.
5, 9, sorry.
So, 6, 5,
Yeah,
9.
we moved it too. No, no.
1.
Oh, you
9,
could.
you understand, so it's 5, 9, 1. And lined up.
Okay. Okay. Peter, don't worry, tomorrow we'll have time, we'll get some reps. Minimal reps, but still reps nonetheless. Right now, this is just your overview, so you know kind of what's going on, and you have notes on how to do it, and some of the important things.
So you're not, just the metric of the OT. So I know you moved it 4 because 250, what did we do with it? We moved it 4 to the left.
I know this.
It's 4 boxes.
So, how I did was I was in the OT direction of
We
625.
moved it from based on the.
Non-standard.
So the azimuth is 625. OT is always an azimuth, so it's 625, so I'm on 625. Then they gave me a left correction of left 200.
Non-standard is.
Okay, well, that's what I mean. Okay.
Left 200, and then I was going to go on.
This is my run.
And then I was going to have a bunch.
Parallel, linear, open, fire. Oh, the wage is supposed to be.
Live something.
This is supposed to
All
be
right.
special sheet, or not special, not non-standard, that's what I said.
Bring it back in, gentlemen. If you have any questions in the back.
Just try to fill in the gaps for knowledge storage. From what I understand, you have parallel, linear, open, converged. There's a fifth sheath.
Special.
Special sheath? That's what you're right? Okay, good to go.
It's basically just anything and everything that you want.
For sure.
Good to go.
Or we make a different one above grounds.
Yes.
Good. Is it not?
It's,
No, no. This is just straight up.
let me see.
There. Now it is.
Right. In all legitimacy, if it's the AMC guys look at it and say it's good, I'll toast it. But all right, cool. So we've got our first set of data, we got our adjustment, and then we have our second set of data. It will continue to be that way until you get a fire for effect. Then you'll fire for effect on that last data, and then you'll get your reps data. So essentially, this is how you translate your call for fire into gun line commands and then gun data. So that's your M16 plotting board there. We're going to go over that into more details in the future. For right now, I'm going to talk about grid, polar, and shift real quick. So we already kind of did grid missions. We received a target grid, we plotted target grid, and then we parallel plotted and prosecuted the target, got our data. For a polar mission, we would do a direction and distance from our FO. So he would give us the direction of, we're just going to use 6250 again. He would give us direction 6250, and then he would do distance 1000. So how I would plot that target is I would orient on 6250 on the OT direction, and then I would use my range arm and go 1000. Exactly 1000. And then I have my target. Once I have my target, I'm going to parallel plot with my MFP, with my mortar position. I'm going to parallel plot with my mortar position. Once I do that, then I'll get my gun data. Same way that I did before. Using referred deflection, using the superimposed numbers to get my deflection, using the azimuth disk numbers to get my azimuth, and then using the range arm to get my range, and then the whiz wheel to get my charge and elevation. Any questions on polar? It's really not that crazy. The only difference is you're not plotting a grid for the target, you're just pulling a direction and distance from the FO. It's the exact same way that you would do it on a map. In fact, most of these are. So shouldn't be crazy. Next is shift from, right? So we'll call this target that we had, Alpha Bravo 2000, that's going to be adjustment 2 on the first target. We'll call that target number Alpha Bravo 2000, and they'll give us shift from, they're going to give us a direction of 6250, and then they're going to give us a left 500 or left 200, drop 100. So then all I'm doing is I'm orienting on that OT direction, and then I'm just doing that correction. Same way that I would do any adjustment. I would do left 200, which is 4 boxes, drop 100, which is 2 boxes, and then I would place my dot. And that would be my new target. And then I would parallel apply, get my deflection, azimuth, range with my range arm, and then charge and elevation with my whiz wheel. The deflection for this one would be actually 3601 with an azimuth of 5849 and a range of 3375 and a charge of charge 3 and elevation 1170. So, something to put in your notes as a reminder. Deflection and azimuth come from your vernier scale. Range comes from your range arm. Charge and elevation come from your whiz wheel or TFT. So that's essentially setting up your board, prosecuting mission,
Right,
your polar,
left subtract.
grid, polar, and shift. Tomorrow we'll get into plotting the gun line and doing linear targets and different sheaves and stuff. We're not going to get into that today though. Alright.
Yeah.
Any questions on the plotting board?
It's written up there, I believe. This is Mars.
Range arm?
Mars is the
Range arm?
function. Browse is
Vernier scale, range arm, whiz wheel, or TFT. Slide azimuth.
Well, it is as it's kind of a potty board. Like you have
On that one that we did the,
look on this is deflection.
polar forward, what was the charging elevation for that?
1 second. Says, what's your question?
For right add, left subtract, I had, what does that have to, remind me again, what does that have to do with the azimuth particularly?
Right add.
Right add, left subtract.
So your azimuth moves clockwise,
Right.
which is right add, left subtract.
So you're just moving right.
Yes.
That's it, okay.
So
And that's your,
whenever you're counting up, if you're counting 1, 2, 3, 4, you would go right. For deflection, it's left add, right subtract. So if you were to count 1, 2, 3, 4, you would go 1,
Okay.
2, 3, 4, left.
so safe to say counterclockwise.
Yes. Azimuth clockwise, deflection counterclockwise.
Yeah. Thank you.
Okay. Just for the sake of the video, make sure we keep the questions open, so that way we can be able to hear all that, and we're not talking over each other too. What's your question?
What's the charging elevation for the polar mission?
Charge and elevation for the polar mission was charge 3, and the elevation was 1180.
And then did you have the deflection and all that for it?
No, I didn't write it down. It's fine. We don't, like, it's still the same, it's still pulling the same data the same way. The only difference was how you plotted the target.
For the range on Darcy up there, what'd you write down for, what is that next to it?
Range arm.
Range arm?
So you're utilizing, so just a reminder, for your deflection in your azimuth, you're using the vernier scale. For your deflection, you're reading
What way? Clockwise or counterclockwise?
Deflection is counterclockwise.
Counterclockwise for deflection, and then for the azimuth is what? Clockwise, right? And then you're going to use your range arm to find your range, putting your MFP on 0, and then measuring it out. And then you're going to use your whiz wheel or your tabulated firing table for charge and elevation. Any more questions on this? We're going to progress if there are any questions. Okay, does anybody need a break? Grab something to eat. Yes.
You can finish off my Doritos if you want.
Alright, take a 5-minute break. Time on deck is 14:08. Come back at 14:12. Alright, so we have gone over the plotting board briefly, a little bit more than briefly. We'll get into a little more detail tomorrow. Now we're going to move on into the actual laying of the gun line, as well as the aiming circle itself. So your aiming circle is right here, your M2A2. I'm not going to move it, but it's going to be right there. I'm going to need you to shift out my battle space here. Alright, so your M2A2, this is your aiming circle. The aiming circle itself is just this portion here to include the dragon egg. Alright, the tripod itself is just an additional part that goes to it. First thing, starting from top to bottom, your elevation micrometer knob with your elevation scale. Alright, this is not going to be extremely necessary for you, but it is mainly just so that way you can rotate to where you're facing the gun line, and then also put it back up into the shape of a V when you're stowing it. So when it's stowed, it needs to be up in a V like that. All right. You have your note that I don't have the nomenclature freaking memorized for the aiming circle, so I'm going to be referring off of my slides here. Oh yeah, look at that. All right. Back here, you see the elbow telescope? Not really elbow, but your little telescope here. And then you have, there's two glass openings here that are like little windows into the aiming circle itself. These two glass openings will show you your magnetic compass needle. Your magnetic compass needle. So not only will this give you azimuth, but how do you actually determine azimuth? You determine azimuth by orienting it with north. So once you orient with actual magnetic north, then you can start implementing your azimuths. All right? And we'll get into how that's done. All right? The rest of this here, this is your main housing. This is your compass locking knob. So the needle that's in here is currently in the locked position. You can unlock it, and it will then try to seek north. I'm not going to do it right now because we're in a building. Compasses don't work in buildings like that, and it's just it could possibly mess it up, and I don't want to do that.
It is very fragile.
Yes. Alrighty. Here on this side, you usually have a cap that comes off, and it will have a filter on it. The filter you would be able to put onto the optics, that way you can see when the sun is like shining through it and you have like glare. Fun fact is that it's also rated for you to put up to your eye and stare at the sun. Just fun fact.
I've tried it, it works.
Yep. On the back, there is a black square where you can write on. This is called your notation pad. This is where you will write down your declination constant. Your declination constant. you just memorizing this? Because if you were memorizing it, I would, yeah, that'd be cool, but I highly doubt it. All right. Behind these two green flaps here, I can open these up, and behind that is your azimuth orientating knobs. So the way to remember these little black knobs here, just put this in your brain. These are the non-recording knobs. The non-recording knobs. This knob here being your wait one. There, you have one level here, one vial for you to level with. So if you were to level this, whoever was here and saw Sergeant Butler leveling it, he would start at 0, level on this axis, and then he would go to, you would go to 4800 and level on this axis. Similarly to how you're doing like elevation and cross level, but your x-axis and your y-axis. To make sure that the bubble is leveled on both axes whenever you're leveling this. All right, and we'll talk about setting up the aiming circle. All right. This is your azimuth micrometer knob. Your azimuth micrometer knob. And this is your azimuth scale. Your azimuth scale. Below this circular piece, this is your base plate. Your base plate. There is also a level on your telescope that you do not need to worry about. I'm actually just going to close this thing up right now. Boom. There is a little rotating green attachment that you can do to close those levels up. We've seen in the past how sometimes our sights get foggy and get like dark. It's because you cannot cover up the bubble. The contents of that bubble is not water. It will eventually just what's it called? Start getting foggy like that if it's exposed to sun for too long. That is why.
So like evaporates out, or
it fogs up the actual like area in here. You know what? Homework for you guys, for somebody, is to figure out the actual contents of the elevation vials. All right. So what is actually inside those vials? All right. In addition, you have your circular level, also known as, well, we just call this the bullseye, or fisheye, whatever you want to call it. Instead of it being a level on like one axis, it's a circular one, so it'll do all axes at the same time. So by the time you're done adjusting this vial on that axis and then on this axis, and you're done with both of them, this vial should be correct. I'm going to rotate this around so you can see. Here is that vial right there, and then this is your fisheye, bullseye, whatever you want to call it, your circular level. You're likely never going to be tested out on aiming circle nomenclature, so like, don't worry about it too much.
Wait, so I have a question. If you're using the other leveling scale to get the X and Y axis, why would you need the fisheye?
The fisheye is just a secondary check. You don't necessarily need the fisheye. Oftentimes, the fisheye actually is the first thing to break on an aiming circle, so you will usually not have it. Or it'll no longer be completely rounded, so it won't actually ever even out the right way. Okay. So that's a nomenclature. When it comes to setting it up, this is what it looks like when it's fully set up.
our legs are fully extended. The legs of our tripod. Note that on the black portion is metal. There's also a green metal piece on the end of each of these legs. The ditty is metal on metal. You want to have that metal piece of the leg it's touching the black metal portion of the extendable leg. So these are metal on metal. My underneath the aiming circle is a locking hand screw. It doesn't have a name. So, but I'm going to cover up the aiming circle real quick so I can take it off. This is by far the most expensive piece that we have.
Why?
Mortars.
You said it's 60, so that's ours was 60.
So, and
This is a surveying tool.
yeah, this is an actual like.
Brand new Derwent.
So this thing is extremely valuable.
It's super valuable. It's extremely important, and it's the only thing aside from the M2 compass that we can use to lay in the gun line. Right? We can use a regular compass. We can use an M2 compass, or we can use our eyes. But this is the most accurate, up to 1 mil.
If you're
Of
really
accuracy.
smart with it, you can do aim, you can lay it by the sun.
That is true. You can't lay in by the sun, but that's a
lot of math.
lot of math.
Could you explain how
No.
that thing works?
What? Dragon egg?
Correct.
The cover?
The dragon
Oh.
eggs are covered. Oh yeah. It's in there.
So, how the dragon egg works is, I'm just going to put this in the starting position real quick. So it goes over the top,
I have
and then it snaps on. I know I lost a few people there, but
What if, like, when we're demonstrating blue sergeant, what if you flat ANCC did not know?
ANCC.
Yeah, bring the
I'm
Bob.
gonna let you guys come here, shots.
all right. At the bottom,
That makes sense.
coming back to this now. All right, at the bottom of your aiming circle, at the bottom of your what is this? Base plate. There's a triangle that flips open, and this locking screw goes into it. All right, might look familiar. All right. So whenever you're setting this up, you want this triangle to be facing you. So the triangle is on the side where my body is at. So then when I put it on the aiming circle, or when I put it on the tripod, I want the triangle to be facing me. Okay? Alright. This is the dragon egg. And then I'm going to stow the tripod. And which one do you want first? I will do a demonstration slowly of putting it together, and then I'll do a demonstration of doing it within time. Like within passing time for AMC. Which one do you want first?
That's both.
Okay, raise your hand for slow.
Okay.
Raise your hand for passing time. Alright, we'll do it slow.
Walk
Can we
Try to do it slow, so like we understand it.
That's what he's doing.
Fast, to where it's like,
Just do it. That's what we're doing right now.
yeah, both.
That's what's going on.
I thought you were coming together.
Look, AMC's fine.
I'm smart with my hands. I am not intelligent with the brain.
Yeah, we know.
You're right.
We know.
Whatever you're saying is being recorded, by the way.
Good. It's bad to go up. Like, I'm smart when it comes to, like, shooting. When he said that, he was telling you to shut the fuck up and go. No.
Alright,
Hey, you need to talk
So-
about Hades.
I forgot the kids. Yeah.
you have gone into your MFP. You are the chief, and your gunner for your vehicle hands you your aiming circle pieces. You run out, and you're going to first set up your tripod. First thing first, you're just going to take a knee. I'm going to do it on the table so that way everybody can see here. There's this strap here. All you're doing, opening up this strap. Now, next, while it is suspended in the air, you don't want to put it on the ground just yet. You're going to unlock your legs and then let gravity do the work for you and let them drop. And you're going to tighten the legs back down so that way metal stays on metal when we add the weight to it. Then I'm going to put one of the spades in the deck so I can open up my tripod. Once my tripod's open, I'm going to get a rough level. I'm going to look at it on this axis. I'm going to look at it on this axis. I'm going to try to get it as little as I can. Remember that the aiming circle is probably about a foot longer than this, so you want to make sure that it's within eye shot here as well. Most people, like per the pubs and everything, it's 36 inches in between each leg, but 36 inches in between each leg looks a lot like. It actually did look pretty correct, but some people do it really, really high up, and then you're sitting there like looking at it. We had a lieutenant one time that was about 6'4", and he set it up to where it was like up here, so then whenever I checked his work, I had to jump to look at it. So try not to do that. All right, once I have my rough level done, I'm going to open this up. You can do another rough level if you want to, just to make it even better. Cool. Then I'm going to grab my Dragon Egg. The proper way to grab your Dragon Egg is you want to put your hand through the strap, grab the bottom, hold it like a canteen. All right. I'm going to open up my triangle. My triangle goes which way? Towards me. So now I'm going to set it down. There is the circle at the bottom of this. This circle here is going to perfectly seat on top of this triangle. There should not be any excess of this circle coming off of this triangle. So when I set it down, I'm going to put my fingers in a triangle motion and try to get metal on, or to try to make the circle flush with the triangle at the bottom. So it'll be hard to see, but you're just going to feel for it. Make sure that circle isn't passing that triangle. Because if it sits like this, bad go. You want it to sit perfectly on the triangle, so that way, whenever you put in your screw, it's almost perfect, it's almost centered. Right? So now my screw is tightened in. I can open up my Dragon Egg. Traditionally, you would stow the Dragon Egg on here, but field scenario, I'm just going to put it back in the box. Then I'm going to level it. So, stowage procedures, you're going to have 3 rotations on top of each of these corkscrews. What are these called? What do you want to call these? Screw. I don't have the nomenclature for these. Screws, cogs, whatever. Sure. I mean, it is a leveling screw, right? But I'm talking about the actual thing itself. But yes, so you want to have 3 spirals on top of the leveling screws. So I've got my 3.
Is it just 3 on top? I thought it was supposed to be 3 top and bottom.
There, you can't see the bottom.
I guess fair.
You might be thinking, yeah. So I've got that. Now I'm going to index 0, and I'm going to start leveling. These 2, so when I'm looking at it, my triangle's right here, my nameplate is right here. So this is the direction that I'm facing right now. These 2 leveling screws work together. They go in opposite directions. So if I were to grab both of them, they're both going to go in, or they're both going to go out. So, reason why that is if one goes in and one goes out, it does this. And if one goes in and one goes out, it does that. So you can see, if I'm putting both in, it's going this way. Make sense?
Wait, so you're only pulling the one closest to you 3 times, or the all 3 that you're sliding 2 times?
These two, these are the ones further from me. I am going in and out based on the level. But that is for when I rotate over. So I'll just do it right now. I'm at 4800 and I want to get this level, so I'm going to rotate these until my bubble is perfect. Similar to how you would a cross level, just like making sure it's perfectly fine. It's good. Then I'm going to go to 0, and then I'm going to use the one closest to me. The one closest to me is going to work alone, and it's just going to go up and down. So I'm going to bring it down, because my bubble is on this side. Bringing it down, bringing it down, bringing it down. All right. And it's perfect. And then I'm going to go back to 4800. I'm going to double check it. It's off a little bit now that I've changed the angle slightly. It's good. It's good. And now I'm level. Now that my aiming circle is level, now I can start getting my numbers together so I can lay in the gun line. It always has to be perfectly level first. Why do we think that is?
So your data is not moving.
So your data is not off. It's not incorrect, and it's not differentiating in any way. So now, I'm going to go briefly over declinating. It's not something I'm going to hit too much right now. I'm going to talk over it. We can hit it at a later date, like on probably Wednesday. Declinating is the process of getting a declination constant. Declination constant is basically, we all know what a GM angle is. So what's the GM angle for tornado bombs?
That's your uniform.
Yeah, that's the grid zone designator. So what's the GM angle, the grid magnetic angle for the north?
That's not so key.
No, it's like,
Somewhere.
It's an 11.
32.
I completely forgot.
I don't remember either.
Alright, it should be 11.8 or 12. From last time I checked. Once again, I also haven't been here in a few months, so it could have changed, right? But the GM angle, essentially finding the deck constant, the declination constant, is using the GM angle and plugging that into your aiming circle. The aiming circle is going to have its own mechanical deviation from that. So it's finding the difference between the mechanical deviation and the actual GM angle. How that works is you have 3 known points, 3 to 4 known points, and a surveyed point. Your aiming circle is going to be on top of that surveyed point, and you're going to basically, the process is run, Nelly, run. You're going to record, non-record, and then record onto those. So, I'm not going to do it, dude. Not right now. Run, Nelly, run is the acronym for record, non-record, record. What that does, you get it. I'm good, sorry.
Alright, so run Nelly run, you're recording the number that's given to you on that survey point, then you're non-recording to the quadrant, and then you're recording north, and it's going to give you a certain number. It's going to give you the first of 4 for that deck constant. You're going to do that 4 times or you're going to do that 1 time for each of those survey points, and then you're going to add them all, divide by 4, so like getting the median or the mean of all of them, and it's going to come out with that deck constant. All right, once again, I'll go over this more on a later date, but just know that the last time I decked this was about 3 months ago, and 3-ish months ago.
Yeah, that sounds about right.
Yeah, because 6 months ago they didn't have a deck station.
Yeah.
So it's about 3 to 4 months old, but last time I decked it, I came out with 0184. So 0184 is the mil difference from grid to magnetic in regards to this aiming circle in particular. So think about it this way. You have a GM angle that is in reference to all maps and your map to your compass. Your map to your compass. You have your GM angle that's in reference to your map and your compass. But the aiming circle needs to be more accurate than a compass. Does anybody know the marginal error within a compass that they are allowed to give to you when it is issued?
2 mils.
No. 3? No. When you receive a compass, it can be up to 4 degrees off. Degrees. So that's like a lot of mils. What's 17.77 times 4? Whatever number that is, it's a lot of mils, right? So if it's 4 degrees off, then it's a deadline to compass. So it can be 3 degrees off, and they'll still call that good. But that's not good enough for mortars, because 3 degrees, that's 71 mils.
Yeah, you know,
4 mils.
almost pushing fucking like 72 almost.
Yeah, it's
Alright.
a crazy amount, right? So we want to be more accurate than that. So we are taking the error out of the aiming circle. Technically speaking, you can declinate a compass. You can also declinate an M2 compass. And that will also get you more accurate.
You didn't call M2, did you?
Huh?
Do we even have an M2?
I have an M2. I
Oh,
own
that's
I
right.
own an M2.
I forgot about that.
Yeah.
Because I don't even know if a long range has one. Which one works?
I've never actually used it in the field. I don't think we're going to, so I don't think they will.
No.
Aiming circle is the most likely. In LAR, they only allow the aiming circle to be used.
It's also, just the most accurate.
Yeah. So you could declinate any of your methods of length, but the aiming circle is the most accurate because it is up to 1 mil of error. 1 mil of error versus the 71 mils of error on a compass. So just food for thought. You technically can lay by compass, but should you ever? Probably not. The only time you're ever gonna, the only time I would ever recommend you actually do it is direct lay and direct alignment. Aside from that, I wouldn't do it at all. I would always do the aiming circle because you can't really direct lay an aiming circle. You can, but like there's no point. It's basically using a rocket launcher to kill a rat. You know. So we've gotten our deck constant. Our deck constant is just basically like the GM angle difference for that aiming circle in particular. All right. Everybody kind of understands at least that portion, right? That's really what matters from what I just talked about. All right.
What did Nelly stand for?
Non-record.
Non-recording?
Yeah, so kind of just a quick walkthrough of how that looks. This is your recording knob. These two are your non-recording knobs. So if I were to record, it
would change the actual number on the azimuth scale. And if I were to non-record, it wouldn't change the number, but it would still change the direction of the aiming circle. Cool? So I would record, then I would non-record, and then I would record again.
And so you said for the first record survey, and then non-record was, what was the number?
So your first record is you're recording the number given to you on the surveyed point. Then your non-record is you're non-recording to said surveyed point. Correction. Backspace. Delete. You are non-recording north. And then you are going to record to that surveyed point. So, let me say it again. You're going to record to the number given to you on the surveyed point. Then you're going to non-record north. And then you're going to record to the actual point, the actual surveyed point. Better way to, a way to visualize it is, actually Peters, stay back there. Robles, just walk like 2 paces back on me. All right, so these two are my surveyed points. I get a number, and the first number is 0250. So I'm gonna go to 0250 on here on my record. Then north is what, this way, right? So I'm gonna non-record north. I'm not actually going to unlock my north-seeking arrow right now because I don't want to break it. So I'm gonna non-record north, and it's non-recorded, and then I'm gonna record back to the surveyed point. And then I'm going to make sure that I'm perfectly on it. And then I'm going to jot down the number that I get. Then I'm going to take the number for my next survey point, put it on. I'm going to record on that. Then I'm going to non-record north. And then I'm going to record to my second survey point. I take those two numbers, I add them together, divide by 2, and then I now have the mean between those two numbers. So I'm getting an average. I'm getting an average between those two numbers. You usually want to always deck at least 2 survey points, but you have access to 4 usually. So you want to try to do all 4.
Also, going back to what Sir Humphrey was saying about, for yes, not unlocking the north-seeking arrow because we're inside of the room, you will also not unlock your north-seeking arrow until you are at least somewhat direction towards north.
And stripped of all magnetic
yes.
materials.
Rank, watches, knives, pens with metal in them.
I used to have a senior that took off his belt when he was doing it too.
Like I would have to as well. So if you also, like you're facing more east or west, and then you unlock your north-seeking arrow, it's going to shoot to that direction. And because it's so sensitive, if you look in it, there's very small wires. You will break something.
Yep.
And guess what? Now you can't use it. Ergo, you can't shoot.
And also, the reason why it actually stops in place is there's a rubber stopper on it that goes up and down based on the arrow locking lever. So the locking lever actually pushes that rubber stopper, so that way it makes the north-seeking arrow stop moving. So if you unlock it and then you slam it around, that rubber sometimes can also like melt or do something else. So if you unlock it and there's residue from that rubber on the arrow, then cool, it slams to one side and then it gets stuck on the wall and then it never comes off. In Fuji, we had a aiming circle that would constantly get stuck. That was the reason why. I actually found out is the north-seeking arrow had like that residue on it from the locking lever.
I bet it was 4th.
It was actually,
Would it have been Apache?
Because Comanche had the same issue after us. Because I informed them about that. Anyway, moving on. You have declinated your aiming circle. Now you're out in the field. You've set up your aiming circle and you're about ready to land the gun line. But first, you need to get your data. You need to figure out your data. What is something that we have already determined to prepare ourselves? We've already determined our mounting azimuth. With our mounting azimuth, we can do, or we can, with our mounting azimuth, we could do some friggin' black magic and come up with the numbers that the gun line needs to actually lay in with the gun, or lay in on the direction of fire. This is always, the aiming circle is always the portion where other MOSs are going to call it black magic. Even some other people, like other O341s that don't even know it, still call it black magic because it is just, it's a lot. It's a lot to handle, right? You thought the Vernier scale was bad? Prepare yourselves. All right, so your acronym for this is going to be SADULU. SADULU.
Sad. ULU.
I will write it down. SADULU. SADULU. It means, well, SADULU is in reference to reciprocal lay. So, reciprocal lay being gun line, aiming point, instrument, aiming point identified, deflection, boom. Ready first recheck, boom. Ready second recheck, 0 mils out, gun lay. This is what you need to do prior to even getting to gun line, aiming point, instrument. The acronym states subtract, add, dec constant or declination constant. Upper, lower, upper. Subtract, add, dec constant, upper, lower, upper. All right. Shot in the dark. What do we think that means?
Subtract the data, add some other data, get the declination constant from that, apply to the upper, lower, and then upper again.
I mean, in a very broad term, yeah.
What would be upper and lower?
That's in reference to your cause. So you're upper reporting, lower non-report, north.
So, what data are we getting from the board to put into the jacket or into the aim circle?
You're close. All right. So, what we need to do when we lay in the gun line, are we laying in the gun line on magnetic or grid?
Grid. Is it a grid?
Is it grid?
Well, initially we have it as magnetic because when you get your north, you have to convert to grid.
So think about it. With grid, you're using grid on your maps, your plotting boards, and what have you.
Oh shit!
But
Like
on your guns themselves, they are orienting in the actual direction. The actual direction would be magnetic. So grid is only in reference to maps and stuff. Maps and that type of thing. Because the whole difference between a GM angle is it's a flat surface versus a round surface. I don't know if we have any flat earthers in here, but flat surface versus a round surface. If you're a flat earther, then there is no GM angle. It's all the same. But with a flat surface versus a round surface, there is a certain angle in which north is then different. So based on where you're at, that angle appears differently. So
And also tell you with the ginormous iron deposit in Canada. For the magnetic side of it.
Sure. Yes. So, the way to remember is grid is your flat surface, magnetic is your round surface. So if you're on the gun, are you on a flat surface or a round surface? Round surface, right? Because you're literally on the deck, you're on the ground and not the earth, right? So you're going to be utilizing magnetic.
So it's like the same as like general to major, major to general, like convert the data.
Technically, but remember when I said that your GM angle, our deck constant is basically the GM angle accounting for the mechanical differential in the aiming circle. So instead of using general to major, we're going to use the GM, or we're going to use the deck constant instead of the GM angle. So, what we're going to do is we're going to input grid, input Mills grid into the aiming circle. We're going to subtract that deck constant, and then it's going to shit out magnetic. So that way we could land the gun on. All right? It shits out magnetic via our deck constant. The only reason it's subtract and add, or subtract or add, is depending on the size of the deck constant in correlation with the mounting azimuth itself.
So it's one or the other, not both.
I will explain. So, this is the part that always gets me. I almost always flip-flop. All right. The way to remember. If your mounting azimuth is smaller than your deck constant, you must add 6400 to your mounting azimuth and then subtract the deck constant.
Does that make sense to everybody?
Could you say
So
that?
if you're mounting azimuth,
I will explain it using the freaking azimuth disk in a second. All right, I just need you to write it down. If your mounting azimuth is smaller than the deck constant, add 6400 to your mounting azimuth and then subtract the deck constant. If the mounting azimuth is larger than the deck constant, you just subtract. You don't have to add 6400, you just subtract. I will explain in a second once you're done writing it down.
Did you say inside with the last thing you said? It was larger, you just subtract.
Yes, if your mounting azimuth is larger, your deck constant you just subtract.
All right.
Smaller, you add 6400.
So, in this instance, with the data that we have on the board, my mounting azimuth is 0350. My deck constant that I determined is 0184. Is my mounting azimuth larger or smaller than my deck constant?
Larger.
It is larger, so what are we doing?
Subtracting.
You're just straight up subtracting. So what is 0350 minus 0184?
Was it
0350
minus what?
minus 0184.
Is it 160?
Minus what?
I got 166.
Yeah, I was gonna say.
It is ones. It is
yeah.
in mils, expressed in mils. It is 0166. 0166. Now, say for instance,
that deck constant was the mounting azimuth, and the mounting azimuth was the deck constant. So now the mounting azimuth is smaller, so we'd have to add 6400 to it, and then subtract your friggin' deck constant. And I'll explain why, right? So, check out your azimuth disk. Take a look at this, right? If I had, we're just gonna go with whole numbers, right? If I have 200, 0200 as my, we'll go with my mounting azimuth. And I have my deck constant of 0400. I subtract the 2, I get negative 200. There's no such thing as negative 200. If you looked at an azimuth disk, you would know that negative 200 would be 6200. But what you can do, instead of doing that, you add 6400 to 0200. That gives you 6600. You subtract 400 from it, and it'll still give you 6200. So if you do not have like the helpful chart here to see the difference, then you just add that 6400 to it. Does that make sense?
So,
You said yes. You said yes. Oh, sound like a question. All right, cool. So we've subtracted, added deck constant. Now we're gonna upper, lower, upper. So what was that number that we got? 0166, right?
yes.
So I'm going to go onto my my aiming circle, and first one is upper. So think about your upper is your recording motion, upper recording motion. Your lower is your lower non-recording motion. You can look at it just based on where they're placed. The higher one, recording. The lower one, non-recording. Upper, lower, upper. Cool? All right, so upper recording motion, I'm gonna do 0166, 0166. Then I'm going to lower recording motion, lower non-recording motion. I'm going to non-record north. I'm gonna unlock my north-seeking arrow. I'm going to non-record north. Boom. And then I'm going to upper recording motion to my gun line. Now, my aiming circle is now aligned to the freaking direction of fire, and I can give you the numbers to then get on that. All right. The reason why that works is angle theory, and I'll explain that in a second here. But now I'm on the gun line, and I'm saying gun line, aiming point this instrument, aiming point that instrument, deflection, friggin' 1866.
So would you say you did for the last number?
For the upper, I'm looking at the gun line. All right, so subtract, add, deck constant. So you're subtracting mounting azimuth and deck constant. You're adding 6400 if the mounting azimuth is smaller. Deck constant, upper recording motion onto the freaking magic number that you got from SAD. And then lower recording motion, or lower non-recording motion north. And then upper recording motion towards the gun line. All right. Okay. Shit. So this is where I blow people's minds. Peters hates this one because I always over-explain the shit out of it. So it's gonna be great. You're gonna love it. All right. Who can guess what angle theory is? I'm pretty sure I've explained it to somebody.
You shoot there.
Something like a mirror, like if you can see them, they can see you.
You're not wrong. And you are wrong. What?
Shoot that from an angle.
You're close. You're
You
close.
said it's when you put it to the left or right of you, right?
Keep going. What?
When you aim to the aiming circle, and so left or right of you instead of forward or behind you.
That's what I remember.
Yeah.
We're doing angle theory, or angle theory.
Oh, there you go. You go there, you go there.
And,
It was like, over us.
Oh my gosh, stepped out right down.
yeah, I still didn't say that thing.
Oh, well, really?
Those are two 60-degree angles. Actually, one's 120 and one's 60. Angle theory. You should explain that. Long time ago.
Galaxy
This right here is why I did not go any further in my math career in high school.
Hey, don't worry. I failed my last year of math, so.
They wouldn't let me take any more math because they did so bad.
I passed it only.
All right, so the best way to explain this is if this is your aiming circle here and this is your gun, I'm going to utilize Sedulu so that way my aiming circle is now oriented parallel to the direction of fire. It's oriented parallel to the direction of fire. Now I'm recording and I'm looking at my gun line. The data that I give them from that is going to be the angular difference from when I was facing the direction of fire. Since I'm parallel to the direction of fire, the angular difference that I give them is the angular difference that they need to get up on the direction of fire. So, these are called alternate interior angles. Alternate interior angles. These alternate interior angles, geometry, that type of thing. These alternate interior angles are going to be the same. So the data that I give from the aiming circle will then get them up on the direction of fire.
Yes.
All right. Yeah, I need thumbs if we understand.
Yes.
Top leg less.
Good.
Okay, who's halfway? And so you're down, and you're halfway.
Yes.
All right. All right. What do we not understand?
Oh god.
This.
Have the same angle.
What
All right.
about this do you understand?
This angle equals that.
If it's 180 degrees.
It's the exact same, if you're drawing a line, it's the exact same shape on the opposite side.
Language.
You know what I mean?
So,
Like this.
all
Yeah.
I think I was if there's two boxes.
Go ahead.
Explain it to me in Barney style.
Okay, so Barney style,
Don't
right?
get that.
If you want, I can give the Barney style.
Best way. Okay, no, he's gonna give you a term that's not. I get. Okay.
It's not wrong.
Go ahead.
Back azimuths.
I remember this.
Oh,
They're pulling an azimuth towards you.
Yes.
Get you up on their back azimuth, being the direction of fire.
all right. Yes, essentially, right.
That's the 180, that 180.
Yeah. Just remember that we're utilizing Sedulu to get our aiming circle facing the direction of fire. Once we're facing the direction of fire, we're then going to look towards the gun line. That creates this angle now for us. It creates the angle for us. They are not facing the direction of fire yet. We give them the data to then get up on the direction of fire. Then once they're facing the direction of fire, then we are now parallelly aligned and within 0 to 1 mils away from each other.
Kind of like how Stats sort of like off at that angle.
Yes, so I mean, exactly like, if your mortars are plotted, if your mortars are in position here, he's gonna run off to the corner, and then he's gonna set up his aiming circle right here. He's gonna get up, get it leveled and everything, do Sedulu, get his magic number, shoot out towards y'all, gun line aiming point this instrument, and then it's going to target you guys onto that direction of fire.
And it's operating off of, for example, the direction of fire acting as like a 180-degree plane, and effectively that direction he's facing would be the. Oh, okay, I understand.
Yep. Okay. Yep.
Another question. How does he know where to go? Or does it not matter that much?
It doesn't matter where you're at. You can be here, 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 here. So long as you're doing Sedulu and you're putting those numbers in on your mounting azimuth, the mounting azimuth remains the same, your numbers remain the same, the deck constant remains the same, so you're always gonna end up parallel. The only reason why you wanna break off to like this side or this side is you wanna break off to this side if you are backwards gunning, you wanna break off to this side if you're forwards gunning.
Now because of the side of
The side that the cannon's at in relation to the sight.
so you want to be on the opposite side where the sight is going to be, correct?
You wanna be on the same side of the sight. Because that way the sight can see you.
Oh,
So that's
but,
where did that in the field?
my
really
bad,
fucking back
yeah,
again.
because you're gonna do bad, that's right, you're right. Okay. Makes sense. And then, obviously, just so we're clear, it's gonna be the same thing for each gun, it's just gonna go down the line and get the angle for each one.
Yes.
Okay.
Technically speaking, he can get the angle for one gun and then everybody else can do side to side. Because that gun is on the direction of fire, now they just do side to side, and they're doing the exact same thing. Because, think about this as it goes along. Now, this is the gun that is up on the direction of fire, then they sight to sight, they're now creating that angle to the next gun, creating that alternate interior angle for them, giving them that data, and then getting them up on the direction of fire. So then the next gun is orienting, creating that new angle, giving it to the next gun, getting them up on the direction of fire, and it's working the exact same way for as the aiming circle all the way down.
Oh, God, okay.
Cool. Now do we understand? Do we understand?
I don't understand like how to do it, but I understand what you're saying. Yeah,
When you set up your aiming circle, like I just did, you got it set up, you got it leveled, you did Sedulu, you're subtracting the mounting azimuth from the deck constant, you're adding 6400. If the mounting azimuth is smaller, and then your upper recording to that magic number that you got, your lower non-reporting north, and then your upper recording to the gun line. Once you upper record to the gun line, boom, the angle is made. And then you give them that data, and then it's reciprocal lay from there. Gun line aiming point this instrument, aiming point identified.
So as a mortar, we're aiming at the aiming circle.
The sight is yes.
So then we're going to be correcting the sight.
You're correcting the cannon, yes. Yeah. I mean, if we really wanted to get the cannon back out, we could, but I think most of us got it enough to where we don't really have to break out the cannon. Cool? We good? Man, we good?
Yes, sir.
You're good? Alright, cool, let's push. Alright. Determining the referred deflection. Once you've done reciprocal lay and you've done aiming point this instrument, aim point identified, gun line, 0 mils out, gun laid, then what is next after reciprocal lay? Refer realign, right? So without disturbing the lay of your mortar, refer your sight to whatever your referred deflection is. To determine your referred deflection, your gunner on your gun has to, quite literally, either the gunner or the chief has to look around and see where the stakes can be laid in reference to the terrain. So we kind of talked about it earlier. If there's defilade in front of you, you can't really lay your stakes out there. And if there's a huge slope behind you, you can't really lay your stakes out there, that you can lay them to the left or to the right. Then just use that as your referred deflection. So then a mil number to the nearest hundredth. So like 3200 or 0000 or 0700 or 2700. Any of those work, just to the nearest hundred. Alright? That's determining referred deflection. I'm not going to go too much into it because we already kind of did it. Okay, do I have any questions on the aiming circle in particular, as well as laying in the gun line? No, pretty solid on that. It's not crazy, it is just black magic. So, the amount of times people have seen us working with these and been like, that's some crazy stuff, I don't know what you're doing. It's probably be like, I don't know, not a millionaire, but you'd be pretty rich. All right, Moving on. Do we need
I'd
to
have at
take
least $1.
at least $1? Yeah, at least $1. Do we need to take a break for anything?
I need to use restroom, sorry.
All right, take 5. 15:22. Be back.
Get your rocks.
Take your rock, boy. All right. So next, we're kind of just going to talk a little bit in regards to mind mapping you guys in placing into an MFP, whether or not you're doing it by the vehicle or by foot. You need to know how to do both. So, basis for that, we're going to start with whenever you've received your order and then you are at your AA and you are about to push past your line of departure. All right. So you're about to push past your line of departure. You reach the point in which you're going to break from your convoy. And in this instance, we'll call it, you're in the vehicles, right? You reach the point where you're going to break from the convoy. Some things to remember when you're breaking from the convoy, because, and I promise you, everything that I'm going to talk about here in the next few, like 30 minutes or so, is going to be stuff that happened or didn't happen that we needed to remediate. That is why this was made, and that is why this was asked about a few weeks ago, so that way this can continue. Because lots of times things get left untaught or left unsaid, and then the cycle continues. You know, if you don't teach everything you know, then people are gonna have the same mistakes that you did, right? So that is what this is for. What's up?
Question about leave.
Just don't leave. All right. So when you're breaking from your convoy, first thing you need to know is actually making it to the no-shit release point. You should have a release point per your order on where you're going to be breaking off from, and then notifying the vehicles behind you. Notifying the vehicles behind you. The reason why is there's been times that we were like in the middle of the formation, in the middle of the movement, and we would break off, and it was briefed in the order that we would break off at that point. But then half the convoy followed us to our MFP. Did not make a single bit of sense. We ended up having to radio to them. The vehicle right behind us did not have good comms, so we weren't able to radio to them. We had to radio to the one in front of them, or the one behind them, sorry. So then the rest of the convoy stopped, but then we still had one vehicle following us. So then they're just like, what? They were kind of confused, and we were just angry.
So is that kind of why they start put weapons in the back of convoys now?
No.
In the middle.
You should be in the middle, and the ATs should be one of the more foremost vehicles, the second or third vehicle. Granted, I know what's going on right now with that stuff. Talk about that at a different time. So breaking from your convoy, things to remember, actually utilizing release points, and then actually notifying the vehicles behind you that you're breaking from the formation. All right. When you're setting up your objective rally point, so objective rally point in regards to mortars, in regards to 311 tactics is what? What is our objective rally point?
Kind of tell you where you're going to go before you kick off, go find your MFP, kind of put your crap together.
Right, so it is last cover and conceal position before you are going into that next phase, right? In the instance of an MFP, right, we're going to be covering concealed the entire time, but this is our position that we're going to sit in where we send out leaders recon. All right, so we're going to send out leaders recon so we can find a good MFP. But in the ORP, we're going to set security, stand by until leaders recon has found that good position for us. All right. So characteristics for an ORP. What's up?
For an ORP, from what I remember, might be different from yours.
But don't you usually sit there for like a good 30 minutes and then you'll move on to your actual PV or MFP?
It is dependent on leaders recon.
Okay.
If leaders recon finds an MFP within 5 minutes, you can go there in 5 minutes.
I think I've sat in the ORP for, worst one's like 30, 45 minutes.
Yeah, the worst was about 30 minutes.
Okay.
Because it's like the last concealed spot and it's like open ground that we're not gonna sit in.
So we really had to find a good spot. There was one time when we got into a good cover and concealed ORP, there was nothing else nearby, so we just turned it into the MFP. That's also a thing that you could do, but technically speaking, ORP is for you to set out security and for leaders recon to then go find the actual mortar fire position. When you are acting like dismounted or mounted to dismounted, this is also the place where you would stash your vehicles and then get ready to do ground mounted procedures. Alright? So characteristics for an ORP, you want to make sure that there's cover and concealment. Whenever you're setting in security, you can set in by the clock method, whatever you need to do. In our instance, we have 2 vehicles, right? So we want to set up our machine guns to employ on avenues of approach, right? Set up PDFs. For the leaders recon, you want to have the VCs go out on leaders recon. You also want to have the squad leaders go out on leaders recon. And you want to have the RO go out on leaders recon. So that's like about 5 people. Sometimes you could also bring, it has been done where you could bring a gun with you. Gun 2, sure, you could bring gun 2 with you, but usually it's just your VCs, your squad leaders, and your RO. RO, so that way we can make sure that we're maintaining calm in that location, so that way we don't move there and then suddenly we can't talk to people. So the RO is there for that. The squad leaders are there to make sure that they can set up the locations for their guns, making sure that they clear off a space for the guns to operate in. And then the VCs are traditionally the section leader and the FTC chief. So those guys are there to just make sure that the MFP is good on its own and make sure that there's enough cover and concealment and actually good, like it's a good MFP. You have defilade, you have the ability to be masked in multiple different directions. You have a secondary exit route as well as a potential secondary an alternate and supplementary MFP if need be. So that's what everybody's there for. Leaders Recon will come back and then they will bring everybody to break down the ORP and then set up the MFP. All right. VCs, those the section leader and chief is also going to determine the direction of fire and the GI. When leaders recon, also a note, when leaders recon comes back, you don't have to come back with everybody. What I tend to do is I tend to have the section leader and then the squad leaders go back to go get the vehicle or to go get the guys, while the chief and the RO stays.